Some discussion in the forum about how to find the standard deviation from data. And so I just wanted to explain a few things about standard deviation for you. So the idea is you have a whole bunch of data. There's some numbers, and you basically want to know how spread out that data is. Here's an example about why I might care about that. As a college professor, when I look at exam scores, the mean exam score tells me some information, but it doesn't tell me everything I need to know. So maybe I have a class where the average exam score is a 73. That's not a bad exam score, especially in a math class. But knowing how spread out the data helps me a lot. If the spread is really small, if the scores are really close together, between 0 and 100, that means that all my students are pretty much in the same spot academically. And I would teach them knowing that they all know about the same amount of material. On the other hand, between 0 and 100, if the scores were more spread out, they could still have an average of 73, but in this case, I would know that there were some students who did very well on the exam and some students who didn't do very well at all. And I would teach that class much differently. I would maybe put students in pairs so that they could work together in teams and work from each other. I might break them into groups and have one class where I worked with them more intensely, and another class where I just gave enrichment assignments. I would do much different things in that class than if the students were all in the same spot. Okay, so knowing the spread is really, really important. So, how do we calculate that? Basically, what we want to do is take the average deviation of the data. And there are a lot of different ways to do that, just like there are different ways to find central tendency or average. There are different ways to calculate spread. I'm going to talk about standard deviation, which is the one that we're going to use most often. Here's the idea. Okay, so in the United States, the average height of a woman is 5 foot 4 inches tall. I just Googled that. So 64 inches tall. I happen to be 66 inches tall. So to find my deviation, I take 66 minus 64, and that gives me 2 inches. My deviation is 2 inches. Suppose that somebody else is only 60 inches tall, my neighbor. Her deviation would be -4. Notice that's a negative number. Okay, so if you're below the mean, your deviation is negative. If you're above the mean, your deviation is positive. All right, and we want to take the average of all of those things. So I would take the mean of these numbers, but there's a problem. If I take the mean of all the deviations, the positive ones will cancel out with the negative ones, and I'll always get deviation of 0. That's a problem. So what I do is I square each deviation, and that makes it positive. Okay? So I'm going to take all of my deviations. Each deviation is the data value minus the mean. That's the deviation. Data value minus the mean. I square it to make it positive. And then I want to take the mean of these. So I want to add them up. This sigma means add them up. And then I'm going to divide by how many of them I have. That's the essential idea of the standard deviation. There are a couple of twists to it though, okay? So this is the average of actually the squares of the deviations. First of all, we want to cancel out the squares. So to do that, we're going to take the square root. So that's the first thing that we do. Now, this does not give me exactly the same thing as if I were to take the square root of each number, of each deviation. Okay, but this is how we do it. It gives me a slightly different number. So the square root does that. And second of all, there's a technical reason that comes later in your study of statistics. We get better estimates if we change that n to an n minus 1. So if we divide by 1 less than the number of data values. This has to do with what are called degrees of freedom, which we don't need to worry about in our class, but it does come up in a later statistics class if you go on and study statistics more. But for now, just know that there's a technical reason that instead of dividing by the actual number, we divide by 1 less than the actual number. So far, so good? Okay, so that is the formula for the standard deviation, which we use the S for. Now, in class, we had some people discussing different ways that this formula is calculated. All right, and it looked like, I couldn't really tell from the notation that you're using in class, because Halo doesn't really get us a good way to put in formulas, but some of you looked like you were discussing different formulas that you saw. There is a way to take this formula and convert it into something easier to work with. This is easy to do in Excel. But before Excel existed, this was very tedious because I would have to take each data value, I would have to subtract the mean from it, and then I would have to square it. And so that's an awful lot of work. First, I have to add up everything and divide by how many to get the mean, and then that subtraction and the squaring was numerically tedious. So with some algebra, we can actually come up with a formula that is a little bit simpler than this. If you care about the algebra and want to watch the rest of this, feel free. If you do not care about the algebra and just want to use the formula in the book, that is fine too. If you want to stop this video right now and stop. But I know that we have at least one person in the class that's a little interested in the algebra, so I'm going to show you how that works. Okay? Okay, I'm going to pull this up a little bit, and I'm going to look at this formula. Whoops, let me get rid of that and use the correct pencil. So I'm adding up each data value minus the mean squared, dividing the whole thing by n minus 1. All right. If I FOIL out the x minus x squared, remember FOIL from algebra? This gives you x squared minus 2 times x times the mean plus the mean squared, all divided by n minus 1. Now I'm going to break this into 3 pieces. Okay, if I take the sum of the x squareds and subtract the sum of the 2x minus x bars plus the sum of the x squareds, I can do that. So I'm going to add up the x squared separately. I'm going to subtract off the sum of the 2x times x bars. I'm going to add those separately. And I'm going to add the x bar squared separately, all divided by my n minus 1. Now let's look at the second. I'm going to look at this middle sum. The x bar is a constant, and the 2 is a constant. Okay? So here's an example from simpler algebra. If you had 2 times x1 times 5 plus 2 times x2 times 5 plus 2 times x3 times 5, you could factor out the 2 and the 5. Okay, so I'm using the distributive property backwards to factor out the 2 because there's a 2 in every term, and also to factor out the 5 because there's a 5 in every term. That's what's going on here. The 2 is a constant, and the x bar is also a constant because it's the mean of all the data. It's the same number all the time. So I can factor them out from this sum. Whoops, need a sum in there. Okay. So that's the first thing I'm going to simplify. The next thing I'm going to simplify is that sum of the x bar squared. Okay. That x bar squared is a constant. So for example, if you had 3 squared plus 3 squared plus 3 squared plus 3 squared, you could just count up how many of those squares you have, how many of those 3 squares, and add them. In this case, I have 1, 2, 3, 4 of them. So this becomes 4 times 3 squared. Whoops, not cubed, squared. So I'm going to do the same thing there. X bar squared is a constant, and there are n of them. That's how many data pieces I have. So I'm just going to write that as n times x bar squared over n minus 1. Okay. Whoops. Oh, and there's an n minus 1 right here. So now this formula becomes a lot easier. I have to add up the squares of my data and divide by n minus 1. I have to take the sum of my data divided by n minus 1 times 2 times the mean. And then I have to add n over n minus 1 times the square of the mean. So let's just take, instead of writing like that, I'm going to write mean squared. Okay. So that's the beginning of how this thing is simplified. So I remember somebody in class talking about, oh, it's just x squared in the formula. Okay, that person was probably looking at this type of formula because there are my data values squared. On the other hand, somebody else was saying something about x minus x bar squared. Well, that's from the original formula there. So if you were talking about that, if that's what you were talking about in the discussion, you were basically just looking at 2 different ways to calculate the same thing, depending on whether you had already used that algebra to simplify or not. So that's all I wanted to say about that. Have a good class. I'll see you in the forum, and I'll keep on answering questions in there. Bye-bye.